All right, wanted to show you guys how to do question 4. This is the alternative way to calculate the molar mass. So we didn't go over it in the results section, but turns out it's on your post-lab for the last question. So let's go ahead and work on it. There are some formulas that they gave you, which was what, like in the introduction part, they tell you like Q equals to AT, N equals to AT over F. You can use those, that works too, but I like to show you how you can use dimension analysis to work on it. So the most important thing is you have to write down what the values that you're given. So you're given the current, 1.06 amps, and then you're given the time, okay? And you're also given the grams. So grams here is good. So you'll take the grams divided by the moles of the metal, then you'll be able to get the mole mass. So our goal is to get the moles of metals here. Okay, moles of metals we can get using these two values here. So what's cool is 1.06 amps is actually the same as 1.06 coulombs per second. That's what amps mean, coulomb per second. And then 6 minutes, 23 seconds. Since I have seconds here, I need to go ahead and convert that to just all seconds. So seconds. So that means it's 383 seconds. Okay, so remember 1 minute has 60 seconds, not 100 seconds. But you have this here. I have some students accidentally use 623 seconds and you get a really wrong answer. So you have your seconds here and you have your coulombs per second. So that's how you can get the coulombs. And then you're like, well, what else do you need? You need something called Faraday's constant. Faraday's constant is F, which is 96485 coulombs per moles of electron. Okay, so that's cool. So you start to see how you have seconds. Seconds will link you to coulombs. Coulombs will link you to moles of electrons. And in this case here, you also know that 1 mole of metal is going to be a ratio to 2 moles of electron. It's just the charge here is a 2+ charge. Okay, so that's how you link it all together. So you start at seconds and you end up from seconds go to coulombs. Coulombs go to moles of electrons goes to moles of metal. So you can actually work it all straight through. So you take your seconds, you always start with the seconds because it stands alone. All the other ones are bridges, like connecting pieces. You use the one that doesn't have a connecting piece, it's just standalone value here. So just seconds, 1 unit by itself. And then you convert seconds to coulombs. So 1.06 coulombs, 1 second. Second crosses off. Coulombs goes to moles of electrons, so 96485 coulombs, 1 mole of electron. And then we know that 2 moles of electron is to 1 mole of metal. Okay, so then you cross this coulombs off, moles of electrons off, you get moles of metals. So in this case here, let's see what we get for our number. 1.06. I get 2.10 times 10 to the minus 3 moles of metal, okay? Then they told you the grams of metal is over here, so molar mass literally is going to be 0.140 grams divided by 2.10 times 10 to the minus 3 moles. That should give you your answer. And I get 66.5446, blah, 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 it keeps going. So you round it up because you need, in this case here, you end up using 66.5, or in this case, 67. Okay?